Moving on to another great technology, Nanoramic Laboratories.
Hi, I'm Mitch Koffel, Vice President of Business Development at Nanoramic. And if you can move to the next slide, our legal folks require us to put that in. So if you can move to the next slide, we'll jump right into it. So most of our technology and most of our development right now revolves around electrodes. And where we're finding the most interest, of course, is in the electric vehicle market, but we'll touch on some other markets along the way. What we've been able to do is create a technology that will improve performance in a battery or in any type of electrode. Supercapacitors are another good example, as well as reduce cost while we're doing that. Next slide, please. Some of the benefits that we can bring in addition to the lower cost is the increased energy density in batteries. Another important point for the technology is we're compatible with existing equipment. So we're not asking some of our partners or some of our licensees or customers to go out and spend a lot of money on extra equipment. We can also improve the high and low temperature operation, and we can significantly lower what's called internal impedance. And this relates to everybody's request for faster charging and faster discharging on their battery. And then the other thing is, along with the higher discharge power, is longer cycle life. So our technology eliminates some of the dead space or dead components in the battery that break down under cycling, and we'll talk about that in a second. Thank you for moving on. Electric vehicles is one of the applications. This is where energy density is the biggest play, so that you get more kilometers or more miles for every charge. In the power tool area, it relates back to the internal impedance comment that I made earlier. We want a fast charge and fast discharge on all the power tools. Consumer electronics is cost driven. So that's why we had to focus on the technology development and where we're also trying to drive cost. Grid storage, again, is a long-term application in the market. So you're looking at life, you're looking at cycle life, you're also looking at mean time to failure, which is a benefit. And then aerospace and defense touches on the high temperature and low temperature applications that we can get into with our technology. And medical devices just kind of rounds out the different application criteria or end users that we've seen so far. The guts or the internal engine for what we do is what we call a 3D nanocarbon mesh. We're replacing some of the PVDF and industry standard polymer binders that have gone into batteries for years and years. Personally, I've been in the battery industry for most of my 30 years in business, and we've been chasing these binder-free electrodes forever. We've been able to do this with our neocarbonics electrode technology, and not only is that nanocarbon mesh electrically conductive, but it's also thermally conductive, which has other advantages. Next slide, please. Just going to touch real quickly. We've worked with a number of different battery chemistries. You've probably heard in the lithium-ion battery world, NMC, LFP, LCO, different types of lithium-ion batteries. And all the testing we've done so far says we can work across all of those, and we can work across the standard battery types: cylindrical, pouch, prismatic. Next slide, please. This really gets into the technology, but the key point that I want to make is the picture that you're looking at there is 145 roughly micrometers of electrode thickness, when a standard battery thickness today is only in the 50 to 100 range. So we're looking at double, possibly triple some of the thickness and energy density possibilities. Next slide. And that we've got multiple pathways to revenue. So this is why we have to talk a little bit about our investment strategy and where we're going. I'll touch briefly on the fast cap and thermexic components on following slides, but we've got single-digit billions to multiple billions. Our key business model is that we're not a mass manufacturer. We license our technology, or we JV, or we partner with other manufacturing companies and or end users. Next slide. The ultracapacitor has been around for quite a while. We've been producing and selling this for about 5 or 6 years. Thermexit is a new product for us, a thermal pad with very high thermal conductivity, much higher than anything we've seen in the market so far. And we're just bringing that to market here in 2021. And then I wanted to just spend a second on our timeline. Starting back in 2009, we've received a lot of government funding along the way, NASA, DoD, et cetera. We've released several of our products. We're continuing to get investment from guys like Maribon, Halliburton, and GK. And in 2021, what we're really looking for is to optimize a lot of these technologies into full-sized cells as opposed to just electrodes, so that we can demonstrate all the advantages. So what we're really looking for are two areas. We're looking for opportunities where we can collaborate, whether that's a grant, whether it's a JV, whether it's NRE, and then we're looking for investment from outright investors, because battery electrode development is very expensive. And I think that's the presentation part. Thank you for your attention.
Thank
Mitch,
you.
hi, nice presentation. Thank you. It's here. Quick question on your slide where you talked about capacity rates being doubled or even tripled. The energy consolidation, I guess. Could you give us a basic idea on an electrical vehicle? What would be the difference between that and a combustion engine?
You're still not going to be able to do the kind of mileage or distance that you can do with an ICE. There's just not going to be any comparison there. But what I can give you is a comparison to where the state of the art is today, whether it's a Tesla or some of the new Mach-E or some of those kinds of EVs. And we could increase their distance somewhere in probably the 30 to 40% range.
Okay, thank you.
Mm-hmm. Thanks for the question.
So from a business perspective, is it a pure licensing strategy, or is there like initial kind of proof of concept or early quantity deployment and development that you guys look to do? I'm trying to understand like how we look at the scalability related to productization, right? Because it looks like that might be the barrier.
Mm-hmm. Yeah, yes, exactly. So when we get involved, we'll get involved with some relatively low level proof of concept work, because all of these electrodes are slightly different. It's not a one size fits all. Then from that proof of concept, we typically move into a joint development agreement with the end customer or with the partner that we're looking at, so that we can get this to scale up. And then the third step, of course, is a full license or full joint venture type of arrangement where we look at going to mass manufacturing. Does that answer the question?
Yeah, so in that longer term cycle, you guys become advisors to the entity that's doing the manufacturing. Is that how I should read it?
Yes, correct, because we remain the R&D arm. And an example of this goes back to our first technology of ultra capacitors or supercapacitors, where we've licensed that technology, but we still remain as an R&D resource for our licensee.
Okay, so I guess then the follow-up question is, are you guys currently working with, key manufacturers or firms that would help you kind of productize this on the consumer side?
Yes, specifically the focus has been for electric vehicles and power tools. That's where we've seen the major traction right now. We're working with a couple of the major electric vehicle companies, one of which is in more of the proof of concept phase. The other is in more of the joint development phase of the program. And it takes quite a while, as you probably know, for these automotive companies to adopt new technology. So it's not always how fast we can go at Nanoramic, but how fast our end customer can do their testing and adoption.
Hey, Mitch, real quick question from the aerospace side. You mentioned the technology works at temperature ranges. Does it hold up as well to I'll say the other environmentals that aircraft see in terms of extreme vibe and shock and just general nastiness?
In general, yes, but part of that relates to beyond the electrode. So it's not then we have to get beyond just electrode development into cell development. And we've done cells for oil field, for example, that are very high shock and vibe for 5 miles underground at high temperature. And we're transitioning that now into some of the battery programs that we're working on.
Hey, Mitch, that was a great presentation. This is Saul from Talis. One quick question, sort of on embedded devices where we do use batteries for things and we care about cyber implications of that, such as it's anything that could be impacted, residency, things like that. So have you guys done any research, or is that part of your scope for the technology of how that would affect embedded systems that quite often have to be heavily certified?
Mm-hmm. Yes, we've started down that path, but we have not gone very far down that path. Most of the work that we've done, again, in the last 2 years has been driven more by the electric vehicle market, but we also have a small surface mount ultracapacitor that your company, Talis, has actually been interested in, and we've been in some discussions for certain IoT and sensor type applications.
Thank you.
Mm-hmm.
Wonderful. Moving on to Westlight AI, just make sure you, Mitch, check in the Q&A. You have a couple questions. Thank you
Yes,
so much.
thank you.